The next example I want to go over is an example that was inspired by something I did with my students. So I was teaching my students from the tutorial on this website about the sklearn module. Okay, so in the sklearn module, we have this really cool example, and this is an example of where sheafs can get you to a similar place that the proper software could also get you to. But I would definitely recommend using the right software when it exists. So it's nice that pysheaf can be used as a rapid prototyping tool, but if a better tool exists for your specific application, then you should use that other tool, of course. Here's an example of the proper tool to be using for something like this. Okay, so if you have some grouped data, I love this picture, by the way. It's my favorite picture. I'm trying to enlarge that a bit. I don't know if I can make that any bigger. But this is just showing you what your four-dimensional data look like. So they're points in 4 dimensions, and this is any 2 dimensions that you pick. You can see that the blue points, that's the species called Setosa of iris, that they are pretty well off to the side. In several different dimensions, it's pretty easy to tell that they're not part of the other group. And then there's Varicolor and Virginica. So the Varicolor is the orange ones and the Virginica is the green ones. And you can tell that there are some instances where it's going to be really hard to distinguish them. So over here, you can't tell them apart, but that's okay because that's only sepal width versus sepal length. That ratio is pretty common between those 2 species. However, if you split along another variable, it's really easy to tell them apart, except there are a few points that end up right on that edge no matter how you split the variables. And they go on to actually create, hold on a second, let me find the page. They go on to create these sort of conglomerate variables. So they squish everything down into 2 variables that, 2 variables that never really existed to begin with, but they're, if you've studied this, they're just 2 new variables that represent the space. And then this is a really nice variable space to look at, but even if you look at the edge, there's still a few that no matter how well you try to separate them, there's a few that are going to be kind of in each other's face. Okay, so we expect that maybe we could hopefully use pysheaf to somehow group these guys and then try to tell which is which. And so what I'm going to do is I'm going to use this really naive technique is I'm going to find the centroid in 4 dimensions for each of the species, and then I'm going to say basically is my new point. So I'm going to use training data to figure out where the centroid is on the training data, and then when I look at a new observation, I'm going to add it to each of my sheafs that I'm working with, and then I'm going to say when I add it to one, which one causes the least effect. So let me kind of plot this out for a second. Okay, so here's at a high level what I'm doing with the sheaves. I use sheaf 0 to sort of find the centroid here of the first species, and sheaf 1 to find the centroid of the second species, and sheaf 2 to find the centroid of the second species. And that's all on the training data. It's all trained data. And then I take one individual test point, like let's say this is a test point, and I want to see if I add it to this sheaf, how much more my consistency radius goes up versus if I try to add it to this guy or if I try to add it to this guy. Okay, so I want to see that adding this test point to each of the 3 sheaves will create a difference in the consistency radius. So my original consistency radii are going to look like this, right? And then when I add the test point, it's going to be different because I added the test point. So I'm going to look at all the deltas and the differences, and I'm going to say in which case was it the smallest new increase in the consistency radius. Okay, hopefully that makes sense. I'll go over to the code next. Okay, so what I'm doing in the beginning of this code is, first of all, I'm importing copy because it's going to be really important to make deep copies so I can keep going back to that prior known state easily and effectively. So if you just do a copy on something, you just say like, in Python A equals B, you might not get a deep copy. You might just get a shallow copy. So anyway, if you don't know the difference between deep and shallow copy, ask me, but it's the same in pretty much every programming environment. Okay, so then this other block of code is just basically lifted from that website I just showed you, and that goes down until I get to, let's say, here. I recombine my X and Y so that then I can use other tools to split up. And so I have G0, G1, and G2, which are splitting up the groups based on their species so that I can train 3 separate models, okay? And so that's what I'm doing. Then I'm training 3 separate models. Now, this is just the data. So now I have 3 sets of data. And now is where I start the pysheaf stuff over here in the code. So that's the same as, this is the same obligatory imports I've always used, and I'm going into the pysheaf part of the analysis, okay? And then over here in the code, I am building my original 3 training sheaves, and I keep going until I get to this point. So at this point where I say archival equals copy, deep copy, sheaf, I'm saving off a copy of everything I've done because I'm going to keep going back to that point. This is where I have trained my 3 sheaves based on the training data I've received. And by the way, I can keep changing what that training data is. Where's the magic number here? Up here, I can pick a different random state, and it can be any integer in this range. So I can just change this. I'm specifying my random state so that I have a consistent run every time I do it. But if you leave this parameter out, it will pick a random state for you. So I recommend trying a variety of random states, but controlling for that so that you know which random state you started on. That's typically a good way to work. Okay. And so now I'm going to move down to the archive point again. All right, now, like this doesn't need to be here. That was not useful. I'm going to delete that. Okay, so right here I start the setup for testing all my cases. And J means which of the test cases I'm on. And what I do at this point, and this is why none of this makes any sense. I need to delete that. Because right here, I just go back to the archival state. All right, I always just start with my archival copy, and I make a deep copy of my archival copy so I can go about my way. And over here is where I am adding the new point. This is my test point, and all I'm doing is finding that, originally I found the centroid, and so now I'm seeing how far off this new point is from the old centroid. That's really all I'm doing. Okay, and let me go ahead and run the code. What ends up happening is it actually works surprisingly well. And okay, so usually about 5 cases failed, but I really like this random seed because it makes me look good. But you shouldn't do that. You shouldn't pick your random seed to make yourself look good. So I'll be more honest and show you what is more typical. Okay, this is a more typical case. And so what happens is, because as you remember, species 2 and 1 were really close together, those are the ones that the code is failing to catch. Sometimes it's always miscategorizing a 2 as a 1 or vice versa, but usually it's just mixed. So let me just try a couple more so you don't get the sense that it always goes in one direction. So yeah, usually there's some of each. Usually there's some 1s misclassified as 2s and 2s misclassified as 1s, and that's cool. Okay, so those 2 centroids are not that far apart, and that's why this really naive method is pretty lossy. But again, this is an example to show you that you should use the right tools for the job. But if you don't have a tool doesn't exist yet, the great thing about pysheaf is it can be used to jumpstart your analysis and get you thinking about something, and then maybe the process will lead you to discover tools that already exist that are better for your job. Maybe they won't. Maybe the thing you're trying to understand, there's no tools in existence yet, and maybe you're the one who's going to write them, and you need pysheaf to get you started so that you can think more clearly about the task at hand. Okay, so that's my 2 cents on that example.